Hello and welcome to A-Level Math. This video is the extension of the first video that discusses about the basics of trigonometry, the basics covering the values of trigonometric functions in different quadrants, whether they take positive values or whether they take negative values. And we had also discussed the relationships with negative angles, so sine of minus theta is minus sine theta and so on. So if you haven't seen the video, please go on and watch it, and then we can move on to this video which discusses about some sums and differences of the angles and the values of trigonometric functions in corresponding to those sums or differences. So what we'll be looking at in this video is basically three formula. The first formula is sine A plus B is sine A cos B plus cos A sin B. Okay, so remember, please make note that sine A plus B is not equal to sine A plus sine B. That is never true. It can be true for some cases, but that is not generally true. The general formula for sine A plus B is sine A cos B plus cos A sin B. So this you have to remember. If you ask me the proofs are given in any standard textbook, and we are not going through it because it really forms the part of your question paper in the examination. What is more important is the application of this particular formula. So I leave it to you to go through the proof, but you should go through the proof because it will make you remember this formula and help understand how it is, where and how it is coming from. All right. Okay. So sine of A plus B is known to us. So what we can do, we can derive sine of A minus B, right? So if I ask you what is sine of A minus B, what we do, we just replace B with minus B. So in place of B, we will write minus B. So it becomes cos of minus B and then cos A and sine of minus B. Alright. So sine A remains sine A. What is cos of minus B? Remember, we know from the previous video that cos of minus theta is cos theta. It's not minus cos theta. So cos of minus B is just cos B and plus cos A, and sine of minus theta was minus sine theta. So what we do, we take this minus outside. So it becomes minus sine B, which on being multiplied with this positive value gives us the negative. So we have sine A cos B minus cos A sin B. Okay, so if you remember this formula, you can also derive this formula, but it is always better to remember both of them. Which two formulae? The first formula is this, sine of A plus B sine A cos B plus cos A sin B. And the second formula is this, sine A minus B sine A cos B minus cos A sin B. So remember the sine cos, and then whatever is the sign over here, if it is a minus, then it is a minus. If it is a plus, then it is a plus over here. Alright, so that's it. Remember these two formulae. Okay, now what is the application of this formula? Okay, so until now we had discussed many things, like we can find out the values of sine 225 degree or sine 300 and say 375 degree or anything. So that gives us the value of some bigger angles. But what about this? If I ask you to find out what's the value of sine 15 degree, how are you gonna find it out? Okay, you obviously know that 15 degree is somewhere in the first quadrant. So it is a small little angle over here. So theta is 15 over here, but how are you going to find out the value of sine 15 degrees? Alright, so this formula becomes handy in such cases. We can write down sine 15 degrees as 45 minus 30 degrees, right? And now we can apply the previous formula. Sine of A minus B is sine A cos B minus cos A sin B. So you think of this angle as angle A and this angle as angle B. So what you get is sine A cos B minus cos A and sin B. Alright. So now we know the value of each of these things, and you just need to know your class 10th trigonometry, and that is just sufficient for this question. So sine of 45 degrees 1 by root 2, cos 30 degrees is root 3 by 2 minus 1 over root 2 times half. I think I'm correct. Please drop in the comment section if I'm incorrect. Alright, root 3 by 2 root 2 minus 1 by 2 root 2, that gives us root 3 minus 1 by 2 root 2. Okay, ugly value, but still we can find out the value of sine 15 degree. And similarly, you can find out the value of cos 15 degrees as well. But for that, we need to know the formula for cos a plus b. I'm sorry for making this thing dirty. Okay, let me remove some of these things. Okay, so the formula for cos of a plus b is cosAcosB minus sinAsinB. So remember, when you're having a plus over here, you have a minus sign in between, and it's not sine cos, it's cos cos, sine sine. So sin a plus b was sin a cos b, cos a sin b. But cos of a plus b is cos cos and then sine sine. So you remember this formula. Again, the proof is given in the book, any standard textbook, so I'm not going into the proof, but you should, because if you want to actually learn something, you should always deal with the proofs of mathematics. Mathematics is nothing without proofs. Alright, so again, if we want to derive cos of a minus b from this formula itself, what we do, we just replace b with a minus b. So cos a cos of minus b minus sine a and sine of minus b. Again, we know that cos of minus theta is cos theta, so cos of minus b is just cos b, and sine of minus theta is minus sine theta. So we multiply this minus with this outside minus and it becomes plus. So we get sine a sine b, and that's it. That's the formula. So remember, when it is plus over here, it is minus, and when it is minus over here, it's plus in between. Okay, let's take up one more question. Find out the value. Alright, rather show that the value of sine 105 degrees plus cos 105 degrees is equal to 1 over root 2. Okay, so how can we find out the value of sine 105 degrees? So for finding out the value of sine 105 degree, what we can do, we can write sine 105 as sine 60 plus 45 degrees. Okay, because 60 plus 45 is 105. And now we can apply the formula sine a plus b is sine a cos b plus cos a sin b. So think of this as a and think of this as b. So sine a, so I read as a but I write as 60. It's sine a cos b plus cos a and sine b. You just think of these 60s and 45 as two a and b's in the formula. This will always help you to, first of all, to remember the formula, because you're constantly murmuring the formula, and in the application as well, you will find that you're doing less of the mistakes. Okay, so sine a cos b plus cos a sin b. What is sine 60 degrees? Sine 60 degree is root 3 by 2. Cos 45 is 1 by root 2. Plus cos 60 degree is half, and again 1 by root 2. So what we have is root 3 plus 1 by 2 root 2. So this is the value of sine 105 degrees. Okay. Now, what is cos 105? In the same way, we can write cos 105 as cos 60 plus 45 degree, and cos a plus b is cos a cos b minus sin a and sin b. So just put on the values. Cos 60 degrees is half times 1 by root 2 minus sin 60 degree is root 3 by 2, sin 45 degrees 1 by root 2. So we have 1 minus root 3 by 2 root 2. And this is quite expected as well, right? You see, 1 minus root 3 is something negative because root 3 is 1.732 approximately. So 1 minus 1.732 gives us negative 0.732. So this entire quantity is actually negative, which is expected as well because 105 degrees is some angle in the second quadrant, and we already discussed yesterday, I mean in the previous class, that in the second quadrant cos takes some negative value, and it is turning out to be actually negative, whereas in the second quadrant 105 lies in the second quadrant, sine in the second quadrant is something positive, and we see that we are also having some positive quantity over here. So always make sure that you are thinking about such things as well. If something is expected to give you negative results, just to verify at least that it is indeed giving you negative result. Okay, so now it asks you to find out the sum of these two, sine 105 degrees plus cos 105 degree. So what you do is just add these two values, this one, and verify whether you're getting 1 by root 2 or not. Okay, so if you add them, you get 2 root 2 in the denominator, the common denominator, root 3 plus 1 minus root 3. So root 3 and root 3 gets cancelled out. What you are left with is 2 by 2 root 2, and then 2 and 2 gets cancelled out, and what you are left with is 1 by root 2. So this proves the result. Okay, now let's prove that tan theta plus phi is tan theta plus tan phi. Okay, this is called as phi. If you are not familiar with it, it is called phi. It's just remember we discussed about null sets in the chapter sets. If you haven't, then please click on the I button above. So this is called phi. It denotes the null set, but here phi denotes some angle. Okay, so just like we had A and B as our angles, here we are having theta and phi as our angles. Don't get bogged down and don't get nervous with these Greek letters. They are just letters. Just like we have our A, B, C, D, Greeks have something theta, beta, epsilon, delta, and so on. There is nothing to worry about them. All right. So now we have to prove this result. Okay, so how we start is we write first of all the two formula that we already know, but instead of A and B, we will now write theta and phi. So what is sine theta plus phi? It is sine theta cos phi plus cos theta sine phi. Just instead of A and B, we are having theta and phi. And what is cos theta plus phi? Cos theta plus phi is cos theta cos phi minus sin theta sin phi. Alright, now tan theta plus phi, we already know that tan is equal to sin by cos. So tan theta plus phi is sin theta plus phi divided by cos theta plus phi, and we just put on the values from here for sin theta plus phi and cos theta plus phi. So we get sin theta cos phi plus cos theta sin phi whole divided by cos theta cos phi minus sin theta sin phi. Okay, now what we do, we divide the numerator and the denominator by cos theta cos phi. We divide the numerator and denominator with this quantity. So dividing each of these things, we divide the numerator by cos theta cos phi and the denominator as well by cos theta cos phi. Remember that we can do this because multiplying or dividing the numerator and the denominator with the same number is acceptable. So just for a very simple example, if I give you 2 by 3, then you can multiply any number on numerator or denominator. Say for example 4 4 or anything like 5 5, and even you can divide the numerator and the denominator by the same number. For example, if I have 10 by say 8, then you can divide both of them by 2, and this is what you actually do when you simplify any fraction, right? You actually divide the numerator and the denominator with some common number, and that is what we are doing here. We are dividing the numerator and the denominator with that common quantity cos theta cos phi. So we can do that, right? Okay, so now what we do, we divide this to the entire numerator, so it will split on each of these parts. So it will be dividing this quantity as well and this quantity as well. Okay, so sine theta cos phi divided by cos theta and cos phi. So this quantity goes on each of these two, plus cos theta sin phi divided by cos theta cos phi, and similarly cos theta cos phi will go to each and every one of these quantity in the denominator as well. Cos theta cos phi by cos theta cos phi minus sin theta sin phi by cos theta cos phi. Alright, so I'll just quickly erase this part and see what we finally get on simplification. So now cos phi and cos phi here gets cancelled out. Sin theta by cos theta gives us tan theta, plus cos theta gets cancelled out, and sin phi by cos phi gives us tan phi divided by cos theta gets cancelled out, cos phi also gets cancelled out, so we are left with 1 minus sin theta by cos theta is tan theta, and sin phi by cos phi is tan phi, and this is what we were required to prove. So you have to actually remember these three formula for sine, cos and tan. Remember that sin A plus B is sin A cos B plus cos A sin B. Cos of A plus B is cos A cos B minus sin A sin B. And tan A plus B is tan A plus tan B by whole divided by 1 minus tan A tan B. So this is given in terms of theta and phi, but you can always remember the formula. In fact, I also remember the formula in terms of A and B, every formula. So tan of A plus B is tan A plus tan B by 1 minus tan A tan B. Remember these three formula, and you can apply them anywhere you want where it will be giving you some useful result. Okay, so we know this formula, right? Tan of A plus B is tan A plus tan B by 1 minus tan A tan B. Similarly, we can prove tan of A minus B is tan A minus tan B by 1 plus tan A tan B. So you have to remember these two formula as well, and in order to get the second formula, tan of A minus B, what you do, you just replace this plus B with minus B in this formula. So you will be getting the formula for tan of A minus B. Alright, so remember this formula as well for tan of A minus B, and now we apply this tan of A minus B for this in a similar way that we find the way we found out sine 15 degrees, right? You remember 45 minus 15 degrees. So tan of A minus B is tan A minus tan B divided by 1 plus tan A tan B. So now what is tan 45 degrees? 1. I'm sorry, it's 15 degrees is not 45 minus 15, it is 45 minus 30. So my bad, replace all those 15s with 30. Alright, so 1 minus, what is tan 30 degree? Tan 30 degrees is, I guess, 1 by root 3 divided by 1 plus tan 45 is again 1 into 1 by root 3. So what we have is 1 minus 1 by root 3 by 1 plus 1 by root 3, and you multiply with root 3 in the numerator and denominator. So it will actually, instead of taking LCM, you actually make a habit of multiplying with the multiplying the numerator and denominator with some common number. It will make your calculations a bit faster. So root 3 times 1 is root 3 minus here root 3 and root 3 will get cancelled out. So root 3 minus 1, then root 3 times 1 is root 3 plus here root 3 and root 3 will get cancelled out. So this is our answer. This is the value of tan 15 degrees. Okay. Now, I'll just do one question over here, and the rest three I leave it to you as an exercise. So let's see how we can handle this. To see that it is given sine 36 degrees, cos 9 degrees, plus cos 36 degrees and sine 9 degrees. Okay. So does it remind you of something? Think. Think for a second. It is something of the form sine A cos B plus cos A sine B. You just think of this 36 and 9 as A and B's. So sine 36 cos 9 plus cos 36 sine 9. If you think of this as sine A cos B plus cos A sine B, it's actually sine of A plus B, right? So you can write it as sine of A plus B, which is equal to sine 45 degrees, which is actually 1 by root 2, and this is how you prove it. So similarly, all the three can be proved very easily. You just put down the formula that you know. So just for example, in this question number 2, it is cos A cos B minus sine A sine B, so it is cos of A plus B, so it is cos 50 plus 10. Okay, in similar manner you can proceed with the other questions as well. Alright, one more question. And now to solve this, we'll apply the formula or the theory that we developed in the previous video. So you remember that I told you about those odd even thing. If it is 90 times some odd number, then change sine into cos. And if it is 90 times some even number, then don't change sine into cos. Keep sine as sine. Okay. So what we can do is write down this sine 270 plus theta as something like this. Sine 270 plus theta is sine 90 into 3 plus theta. Okay, so 90 times 3, so this is odd number, so sine will change into cos and then plus theta, so just theta you have to write down. And now you have to see in which quadrant is this 270 plus theta falling. So 90 times 3 is 90 times 1, 90 times 2, 90 times 3, so this is 270, and then plus theta is in the fourth quadrant. So in the fourth quadrant, we know that sine takes a negative value, so what we do is apply a negative sign over here. Alright, so sine 270 plus theta simplifies to minus cos theta. Similarly, sine 270 minus theta can be written as sine 90 times 3 minus theta. Alright, so 90 times 3 is an odd number, so change sine into cos of theta. And now to determine the sine, okay, so 90 times 1, 2 and 3, and then something negative theta, so back in the negative direction, so this goes in the third quadrant, and in the third quadrant we know that sine is negative, so sine is negative over here, so we supply a negative value over here. So again, sine of 270 minus theta gives you minus cos theta. Okay, and lastly we have to find out cos 180 plus theta. So cos 180 plus theta is cos 90 times 2 plus theta. So times 2 means cos will not change into sine, so cos will remain in cos, and theta. And then in order to find out what is the value, 90 times 1, 90 times 2 plus theta goes in the third quadrant. In the third quadrant, cos is negative, so it takes a negative value. Okay, so keep a negative over here, don't mess around with the values over here. Okay, so this becomes minus cos theta. Okay, so just put down everything in the left hand side. So cos theta, you keep it as cos theta only. Sine 270 plus theta is minus cos theta. Then minus sine 270 minus theta was minus cos theta. So minus cos theta, and then plus cos 180 plus theta is minus cos theta, and then you simplify cos theta and cos theta. cos theta and cos theta gets cancelled out. Then minus times minus is a plus cos theta, and then minus cos theta gives you 0. Alright. Okay, so remember that never forget whatever we discussed in the previous video. So you have, in especially in trigonometry, there are more than 70 or 80 formula. I guess we have just discussed 3 of them as of now, sine a plus b, and those, if you consider them as 6, that's your choice. All right, so for one for each of minus and one for each of plus, so there are 6 formulas that we have as of now discussed, and there are more than 70 formulas as far as I remember. So try to never forget whatever we discuss in each and every class. Alright, so we have to prove this result. Sin x plus y by sin x minus y is tan x plus tan y by tan x minus tan y. So how do you think you should proceed along with it? As you see that we have to split out these x and y. So we have to split out these x and y. So what we do, we take the LHS, the left hand side, and then what we do, we apply the formula. Sine of a plus b is sine a cos b plus cos a sine b, and similarly in the denominator we also apply the formula sine a cos b minus cos a sine b, and then we divide the numerator and the denominator with this quantity cos x cos y. We divide the numerator and the denominator with this quantity. So we apply this to each and every term. Okay, so we can cancel cos y here, we can cancel cos x here, we can cancel cos y here, and cos x here, and what we are left with is sin x by cos x is tan x, sin y by cos y is tan y, again sin x by cos x is tan x minus this tan y. So this is what was required to be proved. Okay, this was a quite simple question. Okay, now we are given the values of sine theta and cos theta, and we are told that both theta and phi lie in the first quadrant. So the reason they have mentioned is that in the first quadrant, you know that everything is positive, sine, cos, tan, and everything else is positive. Okay, so you see these two are also positive, so just make sure that you are thinking about it. So suppose if it was given that theta lies in some quadrant, say for example third quadrant, but phi lies in the second quadrant, so you have to accordingly make sure that the signs are consistent. Okay, and then only you proceed further. So sine theta is 15 by 17. So what we do, sine theta is 15 upon 17. So this is perpendicular by hypotenuse. So can you quickly tell me what will be the base? Base will be root over h square minus p square, which is root over 17 square minus 15 square. So 17 squared is 289 minus 15 squared is 225. So what is the difference? It's turning out to be root over 64, which is equal to 8. Alright, so this is what our base turns out to be. So sine theta is 15 by 17. So what is cos theta? Cos theta is base by hypotenuse, which is 8 by 17, and it will be also having positive value because theta lies in the first quadrant. They are saying that theta and phi both lie in the first quadrant. If suppose it was given that theta lies in the second quadrant, then cos theta would be minus 8 by 17, because in the second quadrant cos takes a negative value, so you would have to supply a negative sign with it. Alright, so cos theta would have been in that case minus 8 by 17. but since theta is in the first quadrant, so cos theta takes a positive value. Alright, similarly we are given that cos phi is equal to 12 by 13. I leave it to, sorry, cos phi is 12 by 13. I leave it to you to quickly find out the value of sin phi and validate that it will actually turn out to be, I think, 5 by 13. Okay, just validate it. Okay, so now they are asking us to find out the value of sine theta plus phi. So first of all, we apply the formula. Sine theta plus phi, sine theta cos phi plus cos theta sine phi. Now you see, you know the value of each and everything. Sine theta was already given to you. Cos phi you have just, okay, this was also given to you. Cos theta we have found out 8 by 17 and sine phi we have just found out 5 by 13. You plug in these values and find out the answer. So I'm quickly plugging in these values. 15 by 17. So this gives us 220 by 17 times 13. Okay, you should validate it with your calculations. Okay, now we have to prove tan 56 degrees is something something something. Okay, so how to proceed with this? So if you notice, this 56 is actually 45 plus 11. Alright, and that is what 11 we are having over here. And always, in most of the cases, the second angle's value will be known to you. That means tan 45 is known to you. Okay, so what we do, we always try to split this thing into two parts such that at least one part's value is known to us. So what we do, we write 56 as 45 plus 11 and then we apply the formula. So tan A plus B is tan A plus tan B by 1 minus tan A tan B. And see, the advantage of this is that tan 45 is known to you. It's equal to 1, right? So you just put down its value. 1 plus tan 11 by 1 minus tan 45 is 1 into tan 11, and now we are having all the degrees as 11 and we are almost done. It's just some basic manipulations that we need. So what we do, we need our answer in terms of sine and cos, so we write tan as sine by cos, and in the next step we are done. Sine 11 by cos 11, and then you multiply the numerator and the denominator with cos 11. So 1 times cos 11 is cos 11 plus sine 11. So you just multiply this entire thing with cos 11. So cos 11 times 1 is cos 11, and here cos 11 gets cancelled and you're left with sine 11. Similarly, if you multiply in the denominator as well, then cos 11 into 1 is cos 11 and minus cos 11 gets cancelled out, sine 11, and this is what is to be proved. See, simple, not too difficult. Nothing is too difficult if you concentrate. Okay, so one more question. So questions like this, whenever you see, there are two special types of question. One is this and one involving tan. Whenever you see x, 2x and 3x along with cot, then you have to apply this thing. X plus 2x is equal to 3x. We already know this, right? What do? You just take cot on both the sides. So cot x plus 2x is cot 3x. You start with this. You already know this. So we are not looking at the question actually. We are just starting it off ourselves. So we are starting like this. Cot x plus 2x is cot 3x. So now what you do, you reciprocal on both the sides. So 1 by, or if you want, we can also write the formula. So I leave it to you to determine this formula or derive the formula. Cot A plus B is cot A cot B minus 1 by cot A plus cot B. So this is the formula. You try to just figure out yourself. I give you a hint. Start with tan of A plus B. Write down its formula. Tan of A plus B is tan A plus tan B by 1 minus tan A tan B. And in both the sides do the reciprocal. So on the left hand side you'll be having 1 by tan of a plus b, which will be actually cot of a plus b, and in the right hand side you change the numerator and denominator, you switch their positions and then change everything to cot. You will be getting the answer. Still, if you don't get, then just drop a comment in the comment section. I'll give you some more hints to solve it, and then you can go through the textbooks as well to find out what is the formula. Okay, so we straight away apply this formula here itself. What is cot of a plus b? It's cot a cot b minus 1 by cot a plus cot b, and the right hand side remains as it is. Now what we do, we cross multiply. So it is cot x cot 2x minus 1 is equal to cot 3x cot x plus cot 3x cot 2x. And then what you do, you just take this 1 to the other side and take everything on this side. So cot x cot 2x minus cot x cot 3x minus cot 3x cot 2x is equal to 1, and this is what we were required to prove. So you see, we didn't start with the LHS or the RHS. We just started with something that we already knew. X plus 2x is equal to 3x, and took cot on both the sides. And this is how. So there is one more question that I leave it to you for proving. And just in the same way, you have to start like this. X plus 2x is equal to 3x, and take tan on both the sides instead of cot now. So tan of x plus 2x is tan of 3x. Expand this left hand side and then cross multiply, and you'll be getting the answer. And that's it. Thanks a lot. I hope you are understanding the videos, but still this is not the end. I request you to go through the textbooks and give your best, whatever you can. Do a lot of practice. That is what will make you excel in mathematics. It's just practice harder and smarter. That's it. Thanks a lot. Bye bye. Enjoy.